Morning. Okay. So I would like to start the class today.
Okay, sir.
I hope some of them solved the problems which I gave the last class.
Yes, sir.
So could you show me someone what is the product? Okay, the Huffman products. I would like to know how you solved. Anyone?
Yes, sir. Wait, sir, 1 minute.
How many of them solved that problem? Last class which I gave. Where is the cyclase product, Tarun? Move last step. Still more. Left, right side. Right side. No, down now. Wait. Okay. Okay. Anybody? It's good. Okay. Anybody? Ravi, did you solve? Isaac,
Yes, sir.
show me. Uh, Niche. Okay, but here there is no hydrogen. Okay, two, one, three, four. No hydrogen. C double bond O only will be there. Okay, good. Okay, okay. Today, so one more point in a Hoffman rearrangement. Kindly please note down. Whenever you have a particular stereochemistry, suppose the compound is a chiral. Okay, it has its own stereochemistry, it has its own configuration. When you do an Huffman rearrangement, the product will be also a chiral and the product will be same configuration. For example, if you have an R configuration, the product will be also the same R configuration. For example, I'm just telling you, take acetamide CH3CONH2. Instead of three hydrogen, you substitute three different compounds. One is hydrogen, other one is ethyl, other one is methyl. Then it will be CONH2. That particular carbon next to this amide will be chiral. And that chiral stereochemistry is exactly maintained even after the Huffman rearrangement. That you should know regarding the stereochemistry. Clear? And suppose if you have an R configuration, you will get the same configuration of stereochemistry. Stereochemistry configuration will not change during the Huffman rearrangement. Okay? Hello?
Yes, sir.
Okay. So now I
Yes,
would
sir.
like to move to this Curtius rearrangement. Okay. So the next I would like to move the Curtius reactions. So okay, in this reaction, in this rearrangement also, the intermediate product is isocyanate. There is no doubt. Look at the, I hope all of them see the screen, right? And did you see the screen, right? Students?
Yes, sir. Yes, sir.
Yes. Yes, sir. So, first I would like to know this even Hoffman derangement or Curtis reaction. In both the cases, the isocyanate is the intermediate. Through that only, the next step will proceed, the formation of an amine. In the case of Hoffman derangement, the conversion of amide into the amine. Whereas in the case of Curtis reactions, normally the conversion from azide to amine. Please remember. Okay, in some of the cases it's difficult to form amide, so they can easily form azide. It's very reactive. So the azide preparation, the functional group is RCON3. It has been prepared from this corresponding acyl chloride. So the first step normally, preparation of an acids. That's one of the tedious problem. So any acyl chloride RCOCl, it will be react with an acid Na3. It will form RCON3, and then after that heating it will be form isocyanate. I will explain mechanism slowly later. Next slide. And then treatment of isocyanate with water as usual, just like Hoffman. So again the product will be RNH2. Okay. After isocyanate, the step will be same as Hoffman, but before the isocyanate formation, the things will be different. Okay. First, can anyone draw and show to me how to form the first step? RCOCl2, RCONA3, N3 from sodium azide. Anybody? Just draw in a note and show to me. Do you have any idea how it forms? RCOCl to RCON3. Anyone? I hope all of them should write first acyl chloride RCOCl and then
Yes,
treat it
sir.
with NaNA3 and form RCONA3. Kindly write down that particular um, how it forms. So you should know this actually. So please, one of them should at least to draw that. So that you know this. At least simply in any N3 which is plus and which is minus, how it forms. Acyl chloride, is an electrophile carbon. So the nucleophile attacks. So you just show me that it's just a single step. It's easy one. How it forms. It's very easy. Why this much time? Huh? Isaac? Anybody? People, do you know or not?
Sir, I am showing, sir.
Nitrogen. So plus minus. So when how it Na plus how it attacks Cl. It doesn't form like this. So do whatever I say. Na plus write simply N3 minus. Now that attack N3
one
minus
more.
as Na plus write
Yes,
N3
sir.
minus. Because right now you write like this. Then I will explain next slide the things clearly. Na plus N3 minus. So attack N3
Yes, sir.
minus on carbonyl. N3 minus attack on carbonyl.
Yes, sir.
Carbonyl carbon. Yeah. Attack carbonyl carbon. Move this next. What will happen?
O minus will form, sir.
Right. Oh, move. Shift the bond. Then write the product now. Okay. Then move O minus inside. And chlorine is very good leaving group. And leave the chlorine. Knock out the chlorine. Then write the product.
Yes,
Okay, that's a short way of understanding. Okay, normally.
yes,
Okay,
sir.
first any acyl chloride when it reacts with sodium azide, it will form acyl azide. Okay, acyl chloride will convert into acyl azide by using sodium azide. Okay, right now you should understand like this. This is a better. Now I
Yes,
will
sir.
show you most important thing. Okay, thank you. Listen now. Next is a very important. First, you people should know two different resonating structure for azides. Either way you can write it. Look at my hand first in the screen. Either you can write azide structures. One of the structure is like this: N minus double bond N plus double bond N. Okay, or the other resonating structure, the minus moves inside, and the double bond moves above the nitrogen, so it will get minus. So RCO N minus. Okay, single bond N, triple bond N. This middle nitrogen has a 4 valencies. That's why it's a positive charge. So you can write either way of resonating structure. You should know this. Please understand. My suggestion is second resonating structure is very comfortable. At least one of them you should able to know. If you know one of them, automatically other resonating structure you can able to write. For example, when you want to write from this to this, how do you write it? Anybody? When you wanted to go from second resonating structure to first resonating structure, how do you write it? Anyone? Please write it. When you wanted to go from second resonating structure to first resonating structure, how do you do it? Anybody? Show to me. Isaac. That's it. That's it. That's it. That's it. So you should know that. Okay. So either of two resonating structure you should know. Then after that, what will happen? The nitrogen between, I mean, the bond between the sigma bond between the nitrogen will starts to break. That means the two electrons completely go to the nitrogen and satisfy and leaving as a N2 molecules. Thereby, this nitrogen already have a lone pair, so it formed nitrene as an intermediate is a very important. Okay, it's difficult to isolate, but the intermediate formation is a nitrines. Once the nitrine forms, same logic. Automatically bond moves inside, O minus or O minus comes inside, R group starts to migrate, so same isocyanate is formed. Clear or not? So from
Yes, sir.
from azide structures, nitrine will form. That means N2 is a leaving group. Then nitrine will form. Then nitrine starts, lone pair on nitrine starts to move. R minus migrates and you will get an isocyanate structure. After isocyanate, obviously you know very well it is same like a Hoffman rearrangement. Same like a Hoffman rearrangement. Please remember, after isocyanate, same like a Hoffman. OH minus attacks. Again, O minus will move here. Then O minus comes here. N minus. Then H plus will abstract. Again form RNH2. Same like. So up to isocyanate, the steps will be different. After isocyanate, same like a Hoffman rearrangement. Even water can react. Even methanol can react. Same like Hoffman. Okay, so in Hoffman and also Curtius, both the cases, the intermediate which is formed, the isolatable intermediate is isocyanate. Okay, clear?
Yes,
But
sir.
in Curtius
Yes, sir.
rearrangement, the main thing is starts from azide. Okay, and there the nitrine will be intermediate is forming, but which may not be isolate, which may not be isolate. So it forms a rearrangement and form isocyanate. Okay, after that water molecule will react and then it forms as usual amine product. So this is called as a Curtius rearrangement. Okay, anything conversion of amine from azide is called a Curtius rearrangement. Suppose convert RCONO3 RNH2, they will not give any rearrangement. They will not give any reagents. You should know that how you should do it. Okay? Okay.
Yes, sir.
I hope all should understand. Now let's see who will solve this problem. It's one of the question paper in IIT. Curtis rearrangement. Let's see who will solve this problem.
Which problem, sir?
Wait. I mean, oh, I will not write the problem. Okay. Okay, then today we can solve this one. Okay. Okay, before going this way, I'll stop share because this is very tough problem. We'll see later. That problem we'll see later. Just a minute. Okay. I hope all of them will see the screen, right? Okay. Hello, students.
Yes, sir. Which problem, sir?
You look at the first problem. Take the first problem and please solve the mechanism. Only first problem for practice. Whichever I highlight in the screen, please take that problem and solve that problem and write the mechanism. It is a sodium azide when it react with an acyl chloride and form isocyanate. They didn't ask even after isocyanate, but you please write even after isocyanate also how it forms. do it. Anyone? Hello?
Yes,
Students,
sir.
do you know the
Yes,
first
sir.
problem, right?
Only
Okay, solve,
mechanism.
Yes, sir.
solve it now.
Yes, sir.
Only mechanism.
Mechanism.
Only mechanism, solve it now. Even after isocyanate. Here they gave product isocyanate, but you solve it after isocyanate also and form an amine and show to me.
By adding water.
Yes. Yes.
Okay. Okay.
Yes, sir.
Turn this side. Turn. Um, Tarun, move rectangle way. Okay. Next step. Okay. Next step. And last nitrogen is double bond. Huh? Wait. How this bond moves there? This bond cannot move this nitrogen. That means you don't understand the resonating structure. That's why I'm telling other resonating structure is a better format. You are
Yes,
just
sir.
uh,
Yes,
how
sir.
how this
Yes,
nitrogen
sir.
can double bond move there? How it moves? I already
I'll
told you
again.
in between nitrine is an intermediate. Where did you show the nitrine? Where is the nitrine? This is isocyanate. Where is the nitrine? Tarun.
Yes, sir. I will write it. Like.
Ah,
Sir.
yes. Wait. Move left side. Ravi, move left side. Oh minus. Move left side. This side. Azide, next step, Azide, next, move up. No, Ravi, I want from this step to this step the mechanism. You don't jump. Rearrangement is okay. You don't jump. How do you form azide to isocyanate, right? That step mechanism. That's I want.
Yes, sir.
That's I want. I know this is
Yes,
product
sir.
you can write. Yeah. Write on this mechanism. Because why
Yes,
I am
sir.
telling is this is easy problem. When if I give this that IIT problem, you will not solve. That's why I'm asking you to do that.
Yes, sir.
Yeah, Isaac, show me.
Sir, this was the
Show to me. Oh, wait. Aside. Okay, next step. Aside. Move up. Move up. Here night. Okay. So, but thing is very here not clear. Please understand. First, the nitrogen, the bond will break and move to here. Then it will be formed nitrine. Where is the nitrine intermediate you have shown? Where is the nitrine intermediate?
yes, yes, sir.
Where? No. See, here itself you have to break and form a nitrogen intermediate. Then that's here you have to break nitrogen N2 you go. Okay, then how automatically this will come? No. Here somewhere you are wrong. I will show to you again. All of them, please listen here. Isaac, you listen here.
Yes, sir.
Nitrogen, the bond first, that means break, that means it's neutralized. N2 will leave. Then it will form as a nitrine. Then the lone pair will move, then R will shift. Or you can move O minus, R will shift, whatever. This nitrine you should write. Put it into the bracket once you write nitrine.
Sir,
Yeah.
after this step, sir. After this step,
Which one? Wait.
after this step, we have to write nitrine, sir.
Here itself you have to write nitrine.
This step.
This step where I show them my arrow.
Okay.
Here. Come here. This one, my hand.
Here.
You see it in my hand. You see my hand.
Here.
Yeah. Here N2 you break and form nitrine. First double bond. I mean lone pair. Then lone pair moves. Then shift U.
Okay, sir.
Oh, okay. Here you return. So, okay, good. Wait. So, but you have to break this one first. Okay? You have to break. Then, okay. Wait. This moves and this bond, now you move here. Okay? Then it will form this one. Okay. From here to here only write clearly. From nitrine
Okay.
to isocyanate write clearly and show to me. When you break N2, you form nitrine. Okay? That how it moves, how it forms isocyanate, show to me. Tarun, do the arrow shifting properly. I'm telling you again and again. That means you don't understand the concept. How this bond will move here, this nitrogen, then where it will break? Where is the nitrogen have a positive charge? Tell me now. Tarun, where nitrogen has a positive charge? Tarun, where is the positive charge? It is there. Then how this bond will move there? This bond will move where?
Hello.
N2 will break. N2 will leave off now, sir.
N2 will leave
Format
off.
now.
How it
Oh,
will leave off? In what way it will leave
Sir,
off? You are written. Wait, I am coming. You are written nitrogen somewhere the bond that don't be memorized. How N2 will leave? Tell me now. You are taking this bond into the last nitrogen. How it leaves? Last nitrogen already three valencies satisfied. How it goes there? So this bond will go to this next nitrogen. It has to neutralize, right? Properly. Right properly.
sir, I'm showing that, sir.
Okay, you just to show me in rectangle. This not this way. Ravi, show me in rectangle this. Okay, first step leave it. Next step, uh, wait. Move this left side, left side. Move left side. No, this side. How nitrine will form? Yeah, this okay. This bond will break. Then you will get it. Move. Then you will get nitrine. This move. Okay. Now okay. Okay. So yeah.
Next here continuation, sir.
A continuation you do OH minus and form this
Yes,
water.
sir.
Same like half.
Yes, sir.
That's not a big
Yes,
deal.
sir. I did, sir.
Okay. Okay. Tarun, did you show? Tarun.
1 minute.
So this is the courteous rearrangement. Okay.
Yes, sir.
Okay. Tarun, show to me. Then I'll move to next problem. Just N2 place only you show to me. Other things okay. How nitrogen? Because I don't want to memorize. If you memorize, some new problem will come. You will not able to solve it. It's impossible. You will not solve. Okay. All of them solve the third problem.
Yes, sir.
Third problem, please solve it. All reagent is there and everything is there. You write a mechanism and show to me how it forms.
Sorry, is this, sir?
Wait. Tarun,
Sir,
I'm seeing 1 minute. Tarun,
sir, you
again, you
removed it,
don't
sir.
understand. This bond
Sir,
will never move to this nitrogen. It is not possible. This bond will move to the next nitrogen. The next nitrogen only positive charge.
Sir, one short question, sir.
I will be showing. Wait. So move that you should understand. Tarun, you look here. 1 minute. Look here, Tarun.
Sir,
Please see the screen. How it forms. Where the nitrogen bonds. Where the electron goes to there. Do you see my screen,
Yes,
Tarun?
sir.
Where I am
Yes,
moving,
sir.
shifting electron. Don't be hurry and memorize. This electron goes to neutralize here. Thereby you will get a nitrine, two lone pairs. Then one will move, and R will be moving here and forming an isocyanate. Please understand the concept. When you do next problem, write properly. Okay? And so now all of them solve the third problem. Third problem.
sir, again call, sir.
Yeah. Okay, Tarun, that's
Sir,
good.
one
Okay.
shows.
Do in second problem, third problem, please solve that. Third problem. Hope all of them written problem. Hmm.
Yes, sir.
Yes.
Yes, sir.
What is the first reagent name? Anyone? What
Ethyl,
is? Yeah.
ethyl acetyl chloride.
No. How come acetyl? Ethoxy is there, not ethyl.
ET, what is that? That font is so small, sir.
Huh?
That font is so small, sir.
Font is so
Zoom.
small. Now you visible?
Yes, sir. Ethoxy acetyl chloride.
No, it's okay. It's ethyl chloroformate. Okay. Okay. The name of the compound is ethyl chloroformate. Okay, then solve now. How do you solve this? Everybody try to solve that. Hold on. Hello?
Yes, sir.
Solving, eh? What is the first step? What happened in first step? Anybody?
Ethoxy will leave, sir.
Show to me what is the first step.
Yes, waiting, sir. First step is tough step, sir.
Tough step,
In the
huh?
problem.
Uh,
In the problem.
first step easy, but mechanism may be tough. But first
Yes,
step
sir.
role is very easy. What is the role of first step?
To bring the chlorine, sir, to the
Yes.
main reagent.
Write down. It's very easy. Why tough? Which is nucleophile? Which is electrophile? Look now. Now you don't say it's very tough. It's easy one.
Yes, sir.
Which is a good leaving group? Chlorine or with oxy?
with oxy, sir.
No. Anybody? Isaac? Tarun?
OH minus will attack the carbon in with oxy group, sir.
Yeah, first what will happen? The lone pair and oxygen will attack to the carbonyl on ethyl formate. First do that.
Lone pair of oxygen.
Oxygen in carboxylic acid, no? That will
Yes,
attack
sir.
to the carbonyl group of ethyl chloroformate. Then O
Yes,
minus
sir.
will come. Okay? When
Yes,
O
sir.
minus return, then chlorine will leave.
Yes, sir. Chlorine will leave and attach to the carbonic carboxylic acid one.
Now, see, you write down and I will tell you. First, up to what I said, you write. Chlorine will leave, write
Yes,
a
sir.
structure. Isaac, first structure itself
Sir,
wrong. How come it becomes COOCl? I want the first structure, how it forms. Some of them mechanism not there, but still this mechanism you can able to write. Some of the compound is very difficult sometimes, but in this you can able to write easily.
Sir.
Yes. Okay, good. Then O minus there. No, no, no. Please write full structure. Product, you write full structure. OET, CO minus, Cl. Here OH, no. OH is the remaining you should write. Okay. Then, okay. When O minus comes, this is not OH, O, carbon, everything. This OH should be plus. When it comes minus, when it returns this negative charge, the chlorine will leave and write the product. I tell you now.
Yes, sir. Chlorine will leave, sir.
Yes. Then write the product. Full
Yes,
product
sir.
you write. Write a full product. This benzene, everything you write.
Yes, sir.
Then only you can clear. C double bond O. Yeah. O. No. O. Carbon.
OCl, sir.
No. Whatever. What happened here? That you write. Don't write chlorine. Nothing now. Chlorine is already leaving. Okay. C
Yes,
double
sir.
bond O. Oxygen. With oxygen, what is attached? That you write properly.
Yes, sir. O.
O. What is attached to the O group? Completely right.
Yes, sir.
Carbon. O. C double bond O. Here also C double bond O. OET. 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 Now we clear?
Yes, sir.
Here OH plus is there. That is already is minus H plus. Then it's become O. Okay. Now
Yes, sir.
Cl minus is there separately. Plus Cl minus. Okay.
Plus Cl minus. Yes, sir.
Because that is leaving group. Now
Yes,
what
sir.
will happen? This Cl minus attacks the carbonyl group. And then become O minus.
Yes,
Then
sir.
O minus when it comes here, this is O group is completely good leaving group. Then you will get
So also
COC.
Cl minus will attack where, sir?
Cl minus will attack carbonyl. This carbonyl. Phenyl attached
Which
to
carbonyl,
carbonyl.
sir? Yes,
First
sir.
carbonyl. First carbonyl.
Yes, sir. Yes, sir.
Write down. Yes. O minus. Yes. Write down now. Next step. Write down properly. Write one by one. Now you are slowly learning. So that's why.
Yes, sir.
Okay. O minus. Now O minus comes again to the. Then this group because it's O only. It's a good leaving group. Oxygen like
This one is
O6.
leaving.
Ah, leave. That's all.
Yes, sir.
That's it. Now you write the product. That's all. This is the first
Yes, sir.
step. Do you know that? Hmm.
Yes, sir.
So this is there. That is where you're lacking. Knowledge is very, very good when you have a good knowledge in some subject. Now you
Yes,
understand.
sir.
You can easily write first step. I can easily write it's an acyl chloride. I know the clue,
Yes, sir.
but how it forms,
Yes,
you
sir.
should know that. Okay.
Yes, sir.
Otherwise, it's waste. Okay. Now write the second step. You're
Next
writing
step.
azide.
Yes, sir.
Isaac,
I
wait.
will write.
Isaac, wait. I'll see you. Cl minus. Wait. What is the first step? Isaac, I'm changing. I asked you to change here, Isaac. It's COOCl. It's not possible. It's COCl. Tarun, did you write? Tarun, did you write or not?
Yes, sir. Writing, sir. 1 minute.
Yeah, we're showing that, Isaac. Wait a sec. Okay. But Isaac, you should know how to form the first step. Okay, you have seen when Ravi
Yes,
forms.
sir. I understood, sir.
Okay,
Understood, sir.
okay, then show to me. Show to me. Okay. So, no, little down, little down. Okay, azide. Okay, next step, azide will form. Okay. Again, I don't understand why you people write this resonating structures. Where about single resonating structure, it is easy, no? Move left side.
From the mixture we form nitrate now, sir.
Yes, where is nitrogen formation? You round and show to me.
Yes, sir. We have nitrate formation.
Okay, this is nitrogen. Okay, okay. Okay, you are writing.
Yes, sir.
See, better, my suggestion is don't write this resonating structure before nitrogen step. Write alternative resonating structure and do it. That is easier. There you
Okay,
will
sir.
get a bond, single bond will be there, easy to break, and nitrogen will form. Write down that structure
Okay,
and
sir.
show to me before nitrogen step. Write a single resonating structure, single bond resonating
Okay,
structure,
sir.
and show to me nitrogen.
Sir, is this?
Move rectangle. Show to me in rectangle way. Yeah, yeah. Okay, chlorine will leave. Next step. Oh, this is why. Okay, H is positive. Okay. Then what happened here? Already chlorine you knocked off. Why you return chlorine again? Here chlorine is knocked off. Where is one more chlorine? How we got? No, no, no. My question is, here already chlorine is there. Here also chlorine is there. How come it is possible? Once chlorine knock off, again one more chlorine will not come. This will become ET. Okay, Tarun. Tarun,
Yes, sir.
this will become Et, and chlorine Cl minus will attack the carbonyl of first carbonyl. Then it will become O minus. When it comes back, then it will leave. Write properly. This is not right proper way. Please write the first step properly and show to me. Tarun,
Sir.
write the first step properly. It is wrong. Again, I'm telling no. Chlorine, when chlorine leaves, only Et group will be there. Okay.
Okay, okay, sir. Okay, sir.
Write properly and show to me first step. Then move to the next step. Finished?
Sir,
Yeah.
sir, I did not get the exact format, sir, but I got this one, sir. I should do one more step.
Yeah, that's final step is HCl NH3 plus. That's all. Okay, because chlorine is
Yes,
there,
sir.
it's in form of acid. Okay, show me full thing. I
Yes,
am
sir.
not
Right.
seeing now.
Yes, sir. Yes, sir. One second.
Yes. Then where is
Yes, sir.
nitrine?
From here, sir.
Okay, okay. Nitrine. Where is the nitrine? And give me the nitrine. Okay, good. Now you, whenever you do that, please don't do that. You have to round up. Okay? No, no, no. Here, phenyl. You are shifting to group now.
Yes, sir. Here.
You should round completely, and then it means that's it. It moving. Then you move the arrow because that's understood. The whole thing is moving. Otherwise, it's not over. Next is
Yes, sir.
then afterwards is easy. And finally, HCl is there, so it will become NS3 plus. That's all. HCl.
HCl, sir.
Because chlorine will be leaving now, so HCl will be there in your product. In your reaction,
Yes, sir.
HCl will be there because Cl will be leaving now. So
Yes, sir.
NaCl or something. So then HCl will be there. Put HCl. That's all. NH3 plus and Cl minus. That's it. Amine will form a salt. That's all. That's it. Okay.
Yes, sir.
That's all. Understood? Okay.
Yes, sir.
Yes. So if they give predict product or a product in the mechanism. So you should know, you should go step by step. What is the first reagent, second reagent? If they don't ask detailed mechanism, you write directly COCl, CON3, and then write the product or mechanism accordingly. So why I'm
Yes,
writing
sir.
very very detailed. Sometimes you can skip the directly COCl. You can write first step. But to
Yes, sir.
you people to understand, I'm just asking you to write each and every step. Okay,
Yes,
since
sir.
it's beginning stage. So once you become expert, you can directly say it's the first step is acid chloride, second step acid formation, and third step rearrangement isocyanate. You can easily tell. But since you are
Yes,
beginning,
sir.
so you should know how to write, how to move the bonding, how to arrow show, everything. Okay? And
Yes, sir.
okay then. Anybody? Isaac left, huh? Already. Hmm. Tarun, did you finish?
No, sir.
Okay then. Do one thing. I'll now show you one thing. You take the screenshot and try to solve this problem. Remaining I'll solve next class. You look my screen, take the screenshot and try to solve this problem, which is the right answer. Write the mechanism of this one. Kindly take a screenshot.
Yes, sir.
Understood?
All four
Oh,
problems, sir.
sorry?
All four problems you have to do, sir.
No, no, no. Starting material, reagent, product. Among the four, which is the product?
Okay. Yes, sir.
Okay, but you need to write each and every step mechanism, then only it's possible to find out. It's IIT, exactly IIT question.
Yes, sir.
Courteous rearrangement.
Yes, sir.
Only thing, T butoxide is a base. Please find out. Okay, that's a base. It picks up the
Yes, sir.
proton. That's the clue. Okay, it's exactly courteous. So in IITs, you don't expect same thing will come. Courteous rearrangement, half minute, something in between there, and some extra steps will be there. You should apply your mind acidity or basicity or rearrangement or kind of a proton transfer, something you should know. So among the four choice, which is
Sir.
your choice? Yes, please.
Sir,
Yeah.
what is the second step, sir? Second reagent
That is it.
under
That's
the
what I'm
arrow.
saying. Tertiary butoxide. Potassium
Tertiary
tertiary
butoxide.
butoxide. It's a base.
Yes, sir.
Potassium tertiary butoxide. And third step
Yes,
is
sir.
the water. That means hydrolysis, H3O
Yes,
plus.
sir.
Okay. This you should try to solve. This is exactly IIT question regarding the Curtis rearrangement. Okay.
Yes, sir.
So otherwise I will solve next class because my this app is not comfortable for me to solve. Okay. That's
Yes,
why I'm
sir.
telling you people to do each and every step. Okay.
Yes, sir.
So kindly do it, and I don't know. I will inform next class. Okay, when it is. Okay.
Yes, sir.
Tarun,
Okay, sir.
did you solve that? Not yet, huh?
He left nowadays, sir.
Okay, okay. Okay
He
then, no
came again,
problem.
sir. He came again.
Sorry?
He came again, sir.
You came again. Okay, okay. Tarun, Tarun,
Sir.
did you understand the problem?
Ye- Yes, sir.
Okay then. Okay?
Yes, sir. Yes, sir. Thank you,
Okay.
sir.
Thank you,
Okay,
sir.
sir.